these are the notes for lesson 2.6, linear inequalities in two variables. We talked about inequalities back in chapter 1, and we solved to find what the different values were, and we graphed them on a number line. When we are given two variables with an inequality, we graph it on a coordinate plane. So we're going to talk about what that looks like tonight. So just to recall a couple of things, the first is standard form. If you remember, if we are in standard form for a linear equation, it looks like ax plus by equals c. And most times, it's easier to find the x and y intercepts when we are graphing in standard form. The other thing I want you to remember is for linear inequalities, they contain less than, greater than, less than or equal to, greater than or equal to, instead of an equal sign. And these are used for finding maximum, minimums, tolerances, anything that has to do with minimums and maximums. The next thing to remember is boundary lines, lines which denote the starting point and ending point of a solution area. Line is dashed if we are less than or greater than. So if you remember back when we had linear inequalities in chapter 1, we had open and closed circles. So if it included a point, it was closed. If it did not include the point or was not equal to, it would be an open circle. The same is true with lines when we're graphing inequalities with two variables. So if it is less than or greater than, our line is going to be a dashed line, and it's going to be solid if it's less than or equal to or greater than or equal to. Now, as always, we can always check to see that our solution makes sense, and we can use test points to tell whether our shaded area, our solution is correct. So we can plug in the test points into an inequality. If the result is true, then the test point is on the solution side. If the result is false, then the solution area is on the other side. So again, we can just use these points to test to see that we have the correct solution. Another key thing to remember is that if we multiply or divide by a negative number, remember we have to reverse the symbol. So for number 1, we're going to graph x is less than 2. So the first thing we want to do is graph this like we would any line. So think of this as x equals 2. As we talked about in class, if it's x equals, we know that it is a vertical line through 2. So we're going to plot 2 on the graph, and we're going to plot a vertical line. Now this is where we need to look at our symbol. We have the less than symbol. It is not or equal to. So that means that we are going to have a dashed line. So instead of drawing a solid line, I'm going to draw it dashed. The other thing that we need to do is shade our solution area. So our solution is x is less than 2. So this means that any number that is less than 2 is going to be a solution. So what I want you to do is put your pen on your graph, and if it's less than, we are going to go to the left. So that means that we are going to shade all this area to the left of our line. As I said before, we can choose a test point to make sure that we graphed the correct area. So I'm going to choose an easy point, which would be the origin, or 0, 0. Again, since it's in the shaded area, it should be a correct solution. So what I'm going to do is plug in 0, 0 into my equation. So we have x equals 0, and 0 is less than 2. Yes, it is a true statement, so 0, 0 is part of the solution area. And as you can see in our graph, 0, 0 is in the shaded area, so it is a solution. So again, the test points just help us tell whether our solution is correct or not. So it's just a way of double checking our answer. For the second one, we're graphing y is greater than or equal to negative 3. Again, notice y equals is going to be a horizontal line at y equals negative 3. So go down on your y-axis, and it's going to be a horizontal line. But again, notice our symbol. We have less than or equal to. This means that it's going to be a solid line. And then again, we just need to shade. Now this one is greater than or equal to. So again, put your pen on your line. It's greater than, we are going above. Again, we can choose a test point. Again, I like to choose 0, 0 just because it's the easiest point to plug in. If we plug in 0 to this equation, we have 0 is greater than or equal to negative 3. We know that is true. So again, 0, 0 should be in the shaded solution. For the next example, notice that our equation is in slope-intercept form. We have y equals mx plus b, but we just have that inequality sign. So again, graph this just as you would if it was y is equal to negative 1/2 x plus 2, and then we'll decide whether our line is dashed or solid and figure out where we need to shade. So we're going to start with our y-intercept, just like we do when we graph. So we're going to start at y equals 2. Our slope is negative 1/2. So we're going to go down 1 and to the right 2. We can also go up 1 and to the left 2 to just add an extra point on our line. Now this is where we need to look at our inequality sign. Notice it is greater than, so therefore it is going to be a dashed line. So we're going to write a dashed line through these points. And then the other thing we need to do is to shade. Again, put your pen on your graph. It is greater than, so we are going to shade above. Again, you can choose a test point to determine whether your solution is correct or not. Again, it's totally up to you whether you check your solutions or not, but just know that you can always check to make sure that they are correct. Now notice that the next equation is in slope-intercept form. So there's a couple different ways that we can graph. We can change this to slope-intercept form, and then we can graph it, or we can find the x and y intercepts. Now the only thing with finding the x and y intercepts is we have to use the test point in order to figure out where to shade. So if we change this again to slope-intercept form, then that way we can easily find out how to shade. If we keep it in standard form and find our x and y intercepts, we have to use a test point to figure out where to shade. So let's change this to slope-intercept form. So to change this to slope-intercept form, remember we want y equals, so we want to move 4x first. So we have negative 2y is less than or equal to negative 4x plus 8. And then last, we're going to divide by negative 2. Remember, we have to divide everything by negative 2. And if we divide by negative 2, we also have to flip our symbol. So this is y is greater than or equal to a positive 2x minus 4. So to graph, we're going to start with negative 4 on your y-axis. We're going to go up 2 and over 2. Notice we have greater than or equal to, so that's going to be a solid line. And then to shade, again, put your pencil on your line. It's greater than or equal to, so we're going to shade above the line. Remember, if it's greater than, we go above. If it's less than, we go below the line. Now, like I said, we could have solved this with x and y intercepts. So we could have plugged those in like we did before, and that would tell us where our graph needs to be shaded. I want to show you how to graph this using x and y intercepts. Again, I'm just going to show you a different way. Again, if slope-intercept form makes sense to you, then just leave it like that, and you can just fast forward through this point of the video. If you want to see how to graph using the x and y intercepts and inequalities, by all means watch the video, and you can also write this in your notes as well. So again, to find the x and y intercepts, if we are finding the x-intercept, we make y 0. If we make y 0, then that gets rid of our negative 2y. And we just have 4x is less than or equal to 8. Divide by 4 to solve. So x is less than or equal to 2. Then to find our y-intercept, again, we make x equals 0. If we make x equals 0, 4x equals 0, and that's gone. So we get negative 2y is less than or equal to 8. To get y by itself, we have to divide by a negative 2. Remember, that means we need to switch our signs, so y is greater than or equal to negative 4. Remember, we then graph our x and our y-intercept. At x equals 2, we're going to put a point, and at y equals negative 4, we're going to draw a point. And notice that our symbol is or equal to, so we're going to have a solid line. And this is where it gets a little bit tricky, so we need to graph or shade where our solution is at. So if you look at our values, we have x is less than or equal to 2. So that's going to be any values that are less than where our point is at. For y is greater than or equal to negative 4, again, it's anything greater than negative 4, so it's going to be above. So notice it's going to be this area is shaded below, above the line. And again, changing to slope-intercept form will always work. Intercepts usually work better if we are in slope-intercept form. Example 3 says you have $200 to spend on books and Blu-rays. Books cost $10 and Blu-rays cost $15. Write a linear inequality to represent the number of books, X, and the number of Blu-rays, Y, that you can buy. So again, we have a total of $200 that we can spend. We're buying books and Blu-rays. Books are $10, Blu-rays are $15. So if we're spending $10 per book and we're buying X books, that's going to be 10 times X, because $10 per book. We are also buying Blu-rays, which again we're calling Y, and those are $15. So $15 per Blu-ray will give us 15Y. Now we only have $200 to spend, so can we spend $200? Yes, we can. Can we spend more than $200? If you said no, you are correct. So our inequality that we're going to use is less than or equal to $200. Because again, we can use the full $200, but we can't use anything more than that because we don't have the money. Again, we are in standard form. Now if you look at the numbers that we are working with, they're a lot larger. So in this case, it's probably going to be faster to find your X and Y intercepts. Again, if you want to change this to slope-intercept form, there's nothing wrong with that. That will work. But again, since we're already in standard form, finding your X and Y intercepts is actually going to be faster in this case. So if we first find our X-intercept, again, if we plug in 0 for Y, we are just left with 10X is less than or equal to 200. If we divide by 10, X is less than or equal to 20. To find our Y-intercept, again, we make X equals 0. If we make X equals 0, 10X is gone, and we just have 15Y is less than or equal to 200. Divide by 15, and Y is less than or equal to 13.5. So again, let's graph these on our number line. Now I only have 4 spots, so I'm going to go up by 5s. So it's going to be 5, 10, 15, and 20. So on the x-axis, we're going to 20. On the y-axis, we're going to 13.5. So 5, 10, 13.5 is going to be about here. Now for our graph, we have less than or equal to, so this is going to be a solid line. And we are going to shade less than. So if we look at both of our values, we're going less than that. So if we look at x, we're going to be shading everything that's less than it. If we're looking at y, we're shading everything that's less than it. We're going to be shading this value, or this area right here. Now if you look at the way that I shaded this graph, why did I only graph in the positive first quadrant? If you think about the amount of money that we have to spend, we only have $200. So can we ever go into the negatives? If you said no, you are correct. So in our graph, we should represent that and show that. So when you are graphing, and we cannot go in the negatives because we're dealing with money, your graph should only be in the first quadrant. And again, as always, we can put in a test point and determine whether this is our correct solution, and you would see that it is correct. So again, we can use inequalities when we have more than one variable, and we can look at a coordinate plane to see what our solutions are going to be.